Okay, you don't need to graph these, but if you're curious, I'll pull it up for you at the end, should we have time. Okay, so we have linear equations with three variables. So if we want a single solution, we have to think about how planes interact. What if I only have two planes? Let's say this wall and that wall. Yeah, where do they intersect? At the straight line. So I don't have a single solution. I need a third plane, the ceiling, right? Now they intersect in the corner at one point. So if I have three variables, I need three equations to have a chance at a single solution. Now the crazy thing is, if I have three planes, they could intersect at these lines, but none of those are in common for all three planes. So this would be a dependent system. They could be parallel, in which case they don't intersect at all. Sorry, these are inconsistent. These are all inconsistent. There's no ordered pair that makes all three of them true. Not ordered pair, ordered triple, X, Y, Z. Okay, then we have some examples of dependent systems. And what we're going to mostly deal with in this section, actually, all the problems in this section are going to have a single solution. Is that a lie? Yes, that is a lie. Okay, single solution. Okay, the first thing that we're going to analyze is if you have triangular form. In this case, the second equation is missing your x variable, and the third equation is missing both the x and the y variable. So we call this triangular form, and we like to have triangular form because we can do back substitution. I can solve the last equation for z. If negative 2z is equal to negative 2, how do I solve for z? Divide by negative 2, and we get z is equal to what? 1. We found one solution. Then we can back substitute into the previous equation to say that 2y plus 3z is equal to 9. But we'll plug in 1 for z. So the first step is, let's go ahead and subtract 3 from both sides. We get 2y is equal to 6. Divide by 2. And we get y is equal to 3. Then we can plug into the top equation. In the top equation, we have 2x minus 3y plus z is equal to negative 4. So we'll plug in z is 1, y is 3, and we can solve for x. 2x minus 9 plus 1. So let's go ahead and add 8 to both sides to get 2x is equal to 4, where x is equal to 2. So the answer to this question is 2, 3, 1. Is the ordered triple that will make all three equations true. Are there any questions about this? Order in which you what? No, it doesn't matter which order. Yeah. But it does matter which order you write this in. X first, Y second, Z third. Okay, this is also considered triangular form, even though it's missing the third equation. A system of equations in which the leftmost variable has been eliminated. So we eliminated the x variable, so it's still triangular form in each subsequent row. Okay, so we're going to try to get triangular form essentially by eliminating one variable at a time systematically. Elimination method. You can pick any variable to eliminate. Which looks easiest to eliminate? X variables, Y variables, or Z variables? I think probably Z variables. Okay, but we could eliminate any of them. Z looks simplest just because it's smallest numbers. Simple because coefficients are lowest. Okay, so I'm going to name these equation 1 or row 1, row 2, row 3 for those subsequent equations. So some rules: you must use all rows. Okay, so the first thing I'm going to do is eliminate the z variable by adding equation 1, row 1, plus row. So this would be x minus 2y minus z is equal to -5. 3x plus y plus z is equal to 9. So when we add these equations together, what do we get? Yes, x plus 3x is 4x. So -2y plus y is minus y. -z plus z, these cancel. And that was the whole point. We wanted to eliminate one variable. Eliminate z is equal to 4, yes. So I'm going to call this R3 or equation 3. No, I already have equation 3. This was equation. Okay, I've used equation 1 and equation 2. So now to use all equations, I must use which one? Must use row 3. And I also want to eliminate the same variable. So I want to eliminate z again. So I look here and I say, how could I eliminate z here? I could add it with row 2. Okay, so row 3 is 2x minus y minus z is equal to 1. Row 2 is 3x minus y minus z. No, this is wrong. 3x plus y plus z is equal to 9. So if we add the sides of the equations together, what do we get on the left? 5x is equal to 10. I wanted to eliminate one variable, and I accidentally eliminated 2. 5x is equal to 10. This is equation 5. We'll divide by 5 to get x is equal to 2. So we found x. Now we can plug this into any equation to find y. Which equation do you want to plug into? You want to plug into R1, R2, R3, or R4? R4. Yes, you can do any combination of them. So R4, we'll plug x in here. So we have 4 times 2 minus y is equal to 4. Okay, so let's subtract 8 from both sides. Get -y is equal to -4. 4y is equal to 4. Any questions so far? So we have x and y. How do we find z? Plug into any equation. Which equation looks easiest? Yeah, they're all pretty easy. So plug into any of them, you'll get the same answer. I'm going to plug into R2. 3x plus y plus z is equal to 9. Y is 4. X is 2. 6 plus 4, I guess we'll just say 10 plus z is equal to 9. Subtract 10 from both sides. Z is equal to -1. So my answer is what? 2, 4, -1. It's really hard to do all of these steps without making a tiny error somewhere. So you might plug in to just to double check. 2 minus 8 plus 1. Do we in fact get -5? We do. And it has to be true for all of them. So you'd have to plug in for all of them. Actually, I guess I don't have my solution here. Let me plug into all of them. 3 times 2 plus 4 plus -1. Is that equal to 9? Yeah, 10 minus 1 is in fact 9. And 2 times 2, 4. Minus 4 is 0. Minus -1 is equal to +1. So now I'm sure I'm right because I plugged into all three and it's true for all three. Any questions about this? I'm going to skip to the last problem, which is a type of word problem that you'll see in this section. This will be the best practice for solving another problem. Find the equation of the parabola that passes through these 3 points. If you can imagine making 3 random points, can you find a parabola that goes through them? Okay, what we need to find is the constants, A, B, C. And so these are the unknowns. Let's use the first ordered pair, 1, 2, and plug it in. So if we plug it into our equation, we know that the y value is 2. It's equal to a times the x value squared plus b times the x value plus c. So we're plugging in the x value of 1. We get 2 is equal to a squared, no, sorry, a times 1 squared is a plus b plus c. Are there any questions about this? Let's plug in the next order pair. 2, 15. So the y value is 15. It's equal to a times the x value squared plus b times the x value plus c. So this gives us equation 15 is equal to 4a plus 2b plus c. And so we'll plug in the last word pair, -2, -1, to get the y value of -1 is equal to a times the x value squared plus b times the x value plus c. We'll plug in -2 for x, and we get the equation -1 is equal to 4a minus 2b. Are there any questions about this? So we have a system of equations. We have 3 unknowns, a, b, c. We needed 3 equations to have a chance to solve it. That's why they gave us 3 ordered pairs. Come up with these 3 equations. I'm going to label these row 1, row 2, and row 3. Which variable would be easiest to eliminate? C. They won't all be that easy. So I'm going to practice maybe eliminating A. Let's eliminate A for fun. Okay, I would like these to be opposites using the elimination method. So I'd like to multiply row 1 by what? Yes, row 1 by -4. And I'd like to add it to row 2. Okay, so this is where a lot of mistakes occur. Can you imagine multiplying everything here by -4? What would you get? Minus 4a, minus 4b, minus 4c. We'll keep row 2 the same. 15 is equal to 4a plus 2b plus c. So now we're ready to add these together. -8 plus 15 is equal to, on the right-hand side, the a's cancel by design. It's elimination method. -2b minus 3c. And so we'll call this equation 4, or row 4. Now we've combined row 1 and row 2. We must use row 3 and eliminate the same variable. And eliminate, and you can use row 1 or row 2. Which one would you like to use? So basically we could do row 1 times -4 plus this, or -1 times row 2. -1 times row 2. And let's add it to row 3. So -1 times row 2 would be -15 is equal to -4a minus 2b minus c. Row 3 is equal to -1 equals 4a minus 2b plus c. Oh man, we're going to eliminate 2 variables again. What's that? I wanted to show you one where we don't eliminate 2 variables because that's what we did last time. Let me try -4 times row 1. So -4 times row 1 would be -8 is equal to -4a minus 4b minus 4c. And row 3 is still -1 equals 4a minus 2b plus c. And if we add these together, we get -8 minus plus -1 is -9. And here we eliminate just the a variable by design. Now it's easier if you accidentally eliminate more variables, which is why I wanted to show you one where we didn't. Minus 6b minus 3c. So this is equation 5. Are there any questions so far? Okay, so now we've used all 3 equations to create 2 new equations with 2 variables only, b and c only. So now it's your homework from last night. So would it be easier to eliminate the b variable or the c variable? C. Okay, and we do that by doing, -1 times row 5 plus row 4. There's many ways to do this, right? So that would be 9 is equal to 6b plus 3c. 7 is equal to -2b minus 3c. If we add these together, we get 16 is equal to, we eliminated c by design, and so we get b is equal to, are there any questions about this? So now we need to find a and c. How should we find them? Plug into which equation? So we want to plug into one of these that have only 2 variables. Plug in 7 is equal to -2 times 4 minus 3c. So I'm going to add 8 to both sides. 15 is equal to, so c is equal to -5. And now we can plug into any of the first equations to find a. I'm going to plug into equation 1. 2 is equal to a plus b plus c. B is 4, c is -5. And so I'll add 1 to both sides to get a is equal to 3. So what's my final answer? Y is equal to ax squared plus bx plus c. So y is equal to 3x squared plus 4 minus 5. Are there any questions about this? Okay, I'm going to do a dependent system next. So I want to see how it wants you to write these. Oh, wow. It just says, say it's dependent and infinitely many solutions. Creation of a circle. Okay, so it doesn't actually have you write out the solution set to dependent system like we did before. Okay, so this problem, we do it the same way. You won't know it's dependent when you start. Which variable looks easiest to eliminate? X, Y, or Z? And usually it's just the smallest numbers. So it looks like the X's have the smallest numbers. Row 1, row 2, row 3. It looks like maybe -1 times row 1 plus row 3. So that would eliminate the X variable, right? -2x and 2x. So -2x minus 3y plus 6z is equal to -4. Row 3 remains the same. 2x plus 5y minus 6z is equal to 8. So what's that? We eliminated 2? Okay, that's a bonus. Makes life easier. So we get 2y is equal to 4. Okay, so then y is equal to 2. All right, so I must use equation 2 now. How could I eliminate the x variable using one of the other equations? So yeah, the smallest number 2 and 3 go into is 6. So I'd like to multiply 1 by 3 and 1 by -2. create opposites. So 3 times row 1 minus 2 times row 2, and add the results together. All right, this is where I need to be extra careful to not make a mistake. I hope you guys catch my mistakes. As usual. 6x plus 9y minus 18z equals 12. Negative 6x plus 4y plus 18z is equal to 14. Does that look right? So if we add these rows together, x and z's cancel, so we get 13y is equal to 26. That's not really helpful, huh? Okay, so y is equal to 2 means we can plug that into all three equations, essentially. So that would give us 2x plus 6 minus 6z is equal to 4. 3x. Okay, actually, forget that. We've already proved it's dependent. I'm sorry. This is equation 4, and this is equation 5. So we could do equation 4 plus negative 1 times equation 5. So y is equal to negative y equals negative 2, and we can add them together to get 0 is equal to 0. So just like before, when you get an identity, like 0 is equal to 0, it means there's infinitely many solutions that's dependent. Okay. So I needed to do one more step because I had to combine all three equations, row 1, 2, and 3 together. And notice to come up with equation 4, I used 1 and 3. And I used 1 and 2 to come up with equation 5. So I haven't combined all three of them together yet, 1, 2, and 3, until I combine those together. Then I combine all three together. Now that's all we need to know. So you need to combine all three in order to make your conclusion. Let's try this last one to see if we can show this inconsistent system. Which variable looks easiest to eliminate, x, y, or z? X, yeah. X is just as easy as z to eliminate, right? So let's do 2 times row 1 plus equation 2. Let's eliminate the x variable. 2x plus 6y minus 4z is equal to 4. Just double check all those computations. If you make one tiny error at the beginning, it makes everything awful at the end. So I usually like to double check as I go along. Row 2 is negative 2x minus 4y plus z is equal to 0. So if we add the sides of the equations together, what do we get? 2y minus 3z is equal to 4. So I've combined equations 1 and 2, so I must use equation 3. And I want to eliminate x again, the same variable. Would you prefer to use equation 2 or equation 1? Yeah, equation 1. So let's do 3 times equation 1, and let's add it to equation 3. 3x plus 9y minus 6z is equal to 6. Let me double check. And row 3 is negative 3x minus 7y plus 3z is equal to negative 1. So if we add the sides together, what do we get? 2y minus 3z equals 5. So this is equation 5. Now we need to combine those two together so that we have used row 1, row 2, and row 3. Negative 1 times row 4 plus row 5 would give us negative 2y plus 3z equal negative 4. We'll add it with 2y minus 3z is equal to 5. When we add the sides of the equations together, what do we get? 0 is equal to 1. What do you think? Inconsistent system, no solution. Any questions about this? Okay, if we have only two equations, we can't have a single solution. So that implies that it's either inconsistent if they're parallel planes or dependent, most likely dependent, because two planes will intersect at a line, in which case you have infinitely many solutions along the line. Okay, the last thing is what's called a homogeneous system of equations, where on the right-hand side, they're all equal to 0. And a homogeneous system always has at least one solution when x, y, and z are all 0. Right? 0 times 5, 0 times -2, 0 times -3 is 0. So notice we could plug in 0 in all three equations, and that will always make the equation 0. We call that homogeneous system. This will always be an answer. So the question is that the only answer, or is it dependent? It cannot be inconsistent. Which variable looks easiest to eliminate? Yeah, smallest values, y. So let's do row 1 plus -2 times row 2. 5x minus 2y minus 3z is equal to 0. -6x plus 2y plus 8z is equal to 0. Did I make any mistakes? So the y variable gets eliminated. -x plus 5z is equal to 0. Now I have to use equation 3. So do you want to use equation 1 or 2 combined with it? Equation 2. So maybe -1 times row 2. Okay, so row 3 I'll keep the same. 4x minus y minus 9z is equal to 0. And so the opposite sign of row 2 would be -3x plus y plus 4z is equal to 0. So if we add the sides of the equation together, we get what? X minus 5z is equal to 0. These already cancel, huh? Okay, so row 4 plus row 5. -x plus 5z is equal to 0. X minus 5z is equal to 0. So we add these to get 0 is equal to 0, which means what? Dependent system, infinite solutions.